everyone. In this video, we're going to use various information to write linear equations in slope-intercept form. So in case you've forgotten, that's y equals mx plus b. And in some cases, we'll be using something called the point-slope formula, which is y minus y sub 1 equals m times the quantity of x minus x sub 1. And I'll be sure to explain this to you as soon as we need it. So the directions, given the information in each question, write the equation of the line in slope-intercept form. So each set of information is going to turn into this equation ultimately. So the easiest scenario, which is number 1, is when we are given the value of m, which we know is the slope, and the value of b, which we also know is the y-intercept. And literally, all we're going to have to do is change and substitute the m and the b to the values that they give us. So here's our equation that we're ultimately trying to get. And we're going to change the m to -2 by substituting it in the m spot. And then substituting the b with the -3/4. And we can, of course, leave our answer like that. Or we can undo that change there and just write it as -2x minus 3/4. And we're done. So we didn't need to use this new point-slope formula that I had talked about originally. So everything we needed could just be substituted right into our equation. Number 2, the slope is -3 and the y-intercept is 9. So here is the information we're given. We have to play detective just ever so slightly because we needed to know that the slope is represented with the letter m. So m is -3. And we need to know that the y-intercept is represented with the variable b. So b equals 9. So in order to correctly substitute our information, you had to know which number represented m and which one represented the b. So y equals mx plus b is our goal. We're going to change out and substitute the m for a -3 since it's equal to -3. And we're going to change the b to a +9. And we're done. All right, moving on. Number 3 is a little bit more difficult because we are given that the slope is -1. So that is pretty helpful. We're given that m is -1 because that stands for slope. But we're not given the y-intercept like we were in the last two. We're told that it passes through the point 4, -3. So if you were picturing what's happening here, let me quick sketch this out. So 4, -3 would be somewhere here. And we know that it has a slope of -1, so we'd go down 1 over 1, down 1 over 1, or up 1, left 1. So we know that our line is going to look something like this. But how do we turn that into y equals mx plus b? The easiest way to do that, of course, we know m, but we know our x value and our y value of one of the solutions to the equation. And so if we're given the slope and an xy, or a point, a solution, then we're going to use something called the point-slope formula, which is y minus y sub 1 equals m times the quantity of x minus x sub 1, to take this information and turn it into this. So the point-slope formula is used when we know one of the points that the line passes through, which we do, and we know the slope of the line, which we do. So we're going to switch out and change the y sub 1 to the y value in our solution. So I'm going to enter the -3 in the y sub 1 spot. M, universal for slope, we know that. So we're going to put the -1 in the m spot. And then we're going to switch out x sub 1 for our x value in our point. So again, I'm going to use the point-slope formula to solve for y equals mx plus b, since I'm given a point and the slope. So now I'm just going to clean this up a little bit. So that's going to become y plus 3 I'm going to distribute my negative 1. So negative 1 times x, negative x. Negative 1 times negative 4, 4. And then I'm going to move this 3 over to the other side by subtracting it. And there you have it. There is our slope-intercept form of the equation that passes through the point 4, negative 3, and has a slope of negative 1. I'm going to just kind of use my original diagram here to see if my answer looks close. So we knew the slope was negative 1. According to my equation, it's going to be touching the y-intercept at 1. And had I had graph paper, I would definitely have been right on. So even though it doesn't look like it's touching at 1, mine looks more like it's touching at 2. Well, that's because I didn't have graph paper when I drew it. So there's my answer. In number 4, we are going to do something very, very different. The information we're given is the line is vertical and it passes through the point negative 3, negative 2. So, as always, when you're not really sure what's going on, to sketch it is always a great idea. So negative 3, negative 2, negative 3, negative 2 would be about here. And we know the line is vertical, which goes straight up and down. So how would we write the equation in y equals mx plus b for this line right here? Well, we know that when we have a vertical line, it only has the x in it. So all we have to do is look here at our drawing, or look here at our point. X is negative 3, and there's our equation. So that one was not quite like either of the others, or any of the others. Number 5, the line is parallel to negative x plus 2y equals 4 and passes through the point negative 3, negative 1. So ultimately, our goal is to write the equation as y equals mx plus b. We could use point slope if we knew the point and the slope. And we sort of do, because here's our point. So x sub 1, y sub 1. And we can find our slope by looking at the equation that it's parallel to, because we know that parallel lines have the same slopes. So if I can find what the m is equal to in this equation, then I can use the m and the point in my point slope and ultimately get my y equals mx plus b. Let's just draw a picture here for those of you that aren't quite sure what's going on, because there's a lot of information. I'm going to take this equation here, negative x plus 2y equals 4, and I'm going to graph it. So I'm going to move the x over. So 2y equals x plus 4. Divide everything by 2. So y equals 1/2 x plus 2, and I'm going to graph that. So I'm going to start here at 2 on the y-axis. And then I'm going to go up 1 over 2. So up 1 over 2, or down 1, left 2. Draw my line. So the line that I'm trying to find, or the equation that I'm trying to write, has to be a line that's parallel to that, but it has to pass through the point negative 3, negative 1. So here's the line I'm actually looking for. This is the one I'm trying to find. So because we know that parallel lines have the same slope, I know that m is going to be 1/2. So now I can use my point slope. Y minus y sub 1. So I'm going to substitute y sub 1 with my negative 1. I'm going to substitute my m with 1/2, since I know the slope is 1/2 now. And I'm going to substitute negative 3 into my x sub 1. Clean it up a little bit. So y plus 1, change, and then distribute. So that's going to be 1/2 x plus 3 over 2. So y plus 1 equals 1/2 x plus 1 and 1/2. Oops, I forgot my plus sign. Minus 1, and y equals 1/2 x plus 1/2. There is the equation in slope-intercept form for the line that is parallel to this one right here, but passes through the point -3, -1. Number 6, this time the line is perpendicular. We know that perpendicular slopes have opposite and reciprocal slopes. So if m is equal to a over b, I know that if they're perpendicular, then m will be equal to negative b over a. So we take it and flip-flop it. That would be making it its reciprocal. And then whether it's positive or negative, we make it the opposite. And it's going to pass through this point here. So again, in order to get y equals mx plus b, I am going to be using my point slope formula to do that. So let me copy it down. I do know that my y sub 1 is a -2. I don't know m yet, so let's try to figure that out. So I'm going to go to this equation that we know it's perpendicular to. It is already in y equals mx plus b form. So if m is 1/2, then the m I'm going to use would be the opposite reciprocal of it, which would be -2 over 1, or just -2. And then finished my formula, x minus x sub 1, change, so y plus 2 equals, distribute, -2x plus 8, subtract 2 from both sides, and y equals -2x plus 6. Number 7, the line passes through 1, -3, and -2, 5. So if I knew my slope and my y-intercept, I could just plug them in, but I don't. So I'm going to use my point slope formula. I am given 2 points. I can use either one. It doesn't matter. So I'm just going to use this one. But it wouldn't matter. I could use either one. However, to find what my slope is, I'm going to need to use both of them, because I'm going to have to plug them into my slope formula, which is y2 minus y1, over the difference of x2 and x1. So let's see, 5 minus -3. I always like to go this way for some reason. 5 minus -3 over -2 minus 1 is going to end up being 8 over -3, or -8/3. So I'm ready. Y minus, I chose to use this point, but like I said, it wouldn't matter. Both will give me the same answer at the end. So y minus a -3 is equal to m, which is -8/3, times the quantity of x minus 1. So y plus 3 equals -8/3 x plus 2 and 2/3 minus 3 minus 3. So y equals -8/3 x minus 1/3. And that is my final answer. And again, it wouldn't have mattered if I used this point. So very quickly, I can just show you how that would have worked. So instead of substituting the 1, -3 point, I'm going to use this point. So y minus 5 equals -8/3 times the quantity of x minus a -2, which is just x plus 2. So y minus 5 equals -8/3 x minus 5 and 1/3. Add 5 to both sides, and it will give me the exact same equation. So either way is fine. And last but not least is writing an equation given a table. Now, we're going to assume that it's already linear, that the slope between all of the points, if I checked it, would be the same. So if I did y2 minus y1, and I did x2 minus x1 between all the points, and then divided the two, we're going to know that they would all be the same. I could quick do that just to help you remember, to show you that it is linear. So 9 minus 15 is -6, 3 minus 9 is -6, -3 minus 3 is -6, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, And if I take my difference of my y's and put it over the difference of the x's, I get negative 6 each time. So I know it's linear. So I know my m, and I can use any point I want. So I'm going to choose this one. Some of you might know why I'm choosing that point, because they're both the same. So it's not going to matter which one goes into the y sub 1 or the x sub 1 spot, since they're both the same. So I'm going to use 3, and then my slope is negative 6, x minus my x, which is 3. And again, it doesn't matter. I could use any set of points I want. So y minus 3 equals negative 6x plus 18. Add 3 to both sides. So y equals negative 6x plus 21 is my final answer. And I could even double check my answer, because if I plug a 1 in for x, it should give me 15 as my final answer. So let's just double check it. If I plug in a 1, that's going to give me negative 6 plus 21, which is 15, and that's what I wanted it to be. So I know that I'm pretty confident that my answer is right. So just to recap, if you know your m and your b values right off the bat, if you know those, then you can just plug them in to your equation and be done. If you're not sure what m and b are, then you want to look for point slope. You want to make sure you have an m, or you can determine the slope, and you want to use a point. Excuse me. And you would use this formula, point slope formula, to turn your answers into the y equals mx plus b.